All right, moving on to our next method for factoring. So the last couple of days we've worked on factoring by taking out the greatest common factor. Today we're going to talk about factoring trinomials, which is our most common polynomial we'll deal with. Trinomial meaning it has 3 terms. And today we're going to focus on how to factor when your first leading coefficient is 1. So here it says trinomials are in the form ax squared plus bx plus c. This is the most common form we'll be dealing with. We will first look at how to factor trinomials that have a lead coefficient of 1, meaning that it almost looks like it doesn't even have a lead coefficient. There's no number there, meaning there's a positive 1 there in reality. And we're starting with these simply because they're easier. And we'll spend a couple days on this type, and then we'll talk about what happens when the lead coefficient is not 1 and what we do with that. We won't be using greatest common factor today because if you look at these trinomials of this form, they're not going to have any common factors because the lead coefficient is 1, meaning the largest factor they can have is 1. And then the last term doesn't have a variable, so we can't pull out a variable either. The greatest common factor for all of our problems today would be 1, so using that GCF is not going to help us. It will come back up when we start doing more complex problems though, so that's why we took a look at it first. So first, we're just going to multiply these out. We know that these 2 binomials multiplied together equals this, and we're going to see if we can notice any patterns because our goal is to go from this piece back to this factored form. So I'm going to label my box here where we talked about box method when multiplying, and we'll use the box method again when we talk about trinomials that don't have a lead coefficient of 1 when it's larger than 1. So hopefully you remember that. Okay, so this is what that box method would look like if we were multiplying out. And what we hope that you'll start to notice here is that this is our first term, this is our last term, and these middle terms add to be 6x. So really what we want to ask ourselves when we are trying to solve these is what multiplies to be 8, because we need these 2 to multiply to be 8, but would add up to be 6. So that's what we're going to try to figure out when we are factoring these. So the 2 factors that multiply to 8 add to 6 would be 4 and 2. And that pattern is going to happen every single time as long as our lead coefficient is 1. So now we're just going to spend some time doing some examples. I think I have 4 examples for you total today. So again, we want what are factors of whatever our last term is. In this case, what are factors of 24, whose sum is 10. And I got that from our middle term. So we want it to multiply to be 24 and add to be 10. So we like to use these t-tables when doing this. So factors of 24, numbers that multiply to 24, like 8 and 3 come to mind, but 8 and 3 add to 11. So that's not correct. 12 and 2 would add to be 14. That doesn't work. 6 and 4 do add to be 10. So I would have x plus 6 times x plus 4. This is the factored form of this trinomial. If you wanted to check your work, you could use the box method. So I'll show you on this one. So that'd be x squared, 6x, 4x, and 24. And this does add to be 10x. X squared plus 10x plus 24. So that's me checking my work. But this would be our final answer here. X plus 6 times x plus 4. So new problem. This time we want factors of positive 20 that add to be negative 9. So 10 and 2 come to mind, but that would add to be 12. That doesn't work. 5 and 4 come into mind, and they add to be positive 9, and we need a negative 9. But I could do negative 5 and negative 4 to get that positive 20, but a negative 9. So instead of, last time we did plus x plus 6, x plus 4, because they were positive. This time we'll do subtraction. X minus 5 and x minus 4. Okay, and that's it. That's fully factored. Next example, this time we want factors of negative 14 that add to 5. So 7 and 2 come to mind, but we need 1 to be negative to get a negative product. So 7 and negative 2 does give us positive 5. So I got that one right off the bat. So I'll have x plus 7 and x minus 2. These multiply to be negative 14 and add to be positive 5. Then I'll do one more for us today. This time I want a negative 3, so factors of negative 3 that add to be negative 2. So negative 3 and positive 1 come to mind. Those do add to be negative 2. So I'll have x minus 3 and x plus 1. And sign does matter here. If I had these flipped with a positive 3 and a negative 1, that's a positive 2, which is not what we want. So sign does matter. Order does not matter, though. I could have x plus 1 and x minus 3. That's okay. But the minus needs to be with the 3. The plus needs to be with the 1. The very last slide I have for you today is just kind of your sign cheat sheet. If there are positives all the way across, you're going to have 2 plus signs in your factored binomials. If you have plus on the end, but subtraction in the middle, you're going to have 2 minus signs in your binomials. And then if you have a negative on the end, you're going to have one of each kind. This middle sign could be a positive or negative, but you'll still have one of each kind if you have a minus on the end, because you need one positive and one negative to be multiplied to a negative. If this middle sign is positive, then the larger number is positive. If the middle sign is minus, then the larger number is negative. But this is kind of your sign cheat sheet for when you're factoring. But you're really just asking yourself, what multiplies to my last term adds to my middle term today? So at this point, you do have a short delta math assignment to work on.